All right, we are doing geometry and three-dimensional geometry, which is in itself kind of tricky. So in the instructions, they got to give us enough information. Now, if they're doing a word problem, sometimes we have to figure out, if they're saying to walk around a fence or something like that, that's probably perimeter. Or, if it's tying a ribbon around a circular wedding cake, that's circumference. We do a little bit of thinking. But here they're just coming out and saying, the volume of an antique globe is that amount. And they want us to find the radius. The radius is, when anything around, the radius is the most important number. So we're working backwards a little bit. So we're going to go to our formula sheet. And the thing we're looking for is a sphere. So globe, sphere, ball, any three-dimensional super roundy thing. And we don't want to get lost in circle. Now that says area, we want volume. So sphere, volume. Its volume equals 4/3 times pi times r to the third power. So I'm going to move this over there. Actually, you know what I could do? I could just write it on top of this. Oops, give me my pen back. There we go. So volume equals 4/3 times pi times, I'm putting times dot ins in there to remind myself that those are times, the radius times itself 3 times, or cubed. So make that go away. Alrighty. They gave us the volume. The volume of this sphere thing is 228. So I'm just going to plug in what we have. 228 equals 4/3 times pi times a certain number times itself 3 times. We want to get this number by itself the best we can. Okay, so we're going to get rid of 4/3. Now this is a tricky one. When we want to get rid of a fraction, the way we get rid of a fraction, if it was just 4, times r or whatever, we want to get rid of the 4, we'd put the 4 down here. And that's what would make them cancel out. Well, this one's a little bit different. What we're going to do is we're going to take the 4/3 and flip it upside down. And just because we put it over here, everything's multiplied. It's all of this is times 3/4. And now I'm going to do that over here. This is a tough one. This is a challenge. This is why it's question 20 out of 20. Now these two cancel each other out. That 3 and that 3 cancel each other out. That 4 and that 4 cancel each other out. So this side just got pretty simple. It's pi times the radius to the third power. Now we have some work to do over here. So we always remember, when we multiply fractions, multiply across the top, multiply across the bottom. 228 is a whole number, but it has a 1 down here. So I'm going to get my fancy calculator, and I'm going to multiply across the top. 3 times 228, 3 times 228 equals 684. That's a expressway I grew up near. 684. 4 times 1 is just plain old 4. Now we need to divide this out. 684 divided by 4 is 171. All right, now pi times r to the third power. Well, if we notice, that pi is in the answer. So really, all we got to do is figure out which of these 4 numbers times itself 3 times equals 171. Now, there's other fancy ways to do it with the calculator, but right now, we just did a ton of work. We we plugged in some things. We flipped a fraction. We did that stuff. We got to this number. So I'm going to put this answer on trial, 8.81. So on my calculator, I'm just going to do 8.81 times 8.81 times 8.81. And my answer is 683.79, pretty close to 684. But that's not the number we're looking for. They're just tempting us with that halfway math. 684 is there. We know it's got to be 171. So I'm going to clear, and now I'm going to try this one. 5.55. 5.55 times 5.55 times 5.55 equals, I know you
169 something.
Yep.
170.
And that's our answer. So whenever we put an answer on trial and they put them in order, lowest to highest, pick the middle two.
How come your calculator said 170? Look at what mine said. 160.
I don't know. I might have pressed
169. But either way, you're right. But
yep.
That's weird.
And whenever we deal with circles, we're going to get the hella long decimal. It's going to go on forever. Kids still say hella long? Anyway, we're going to deal in decimals with circles, anything round, because the math just doesn't work out very well. So here's what I'm going to do. I'm going to undo all this. We're going to look at it again. Oops, redo. Now, if they had given us the radius, we would have plugged the radius, multiplied itself by itself 3 times, then multiplied it off this fraction, multiplied it by pi, and then we would have gotten our answer. But they're giving us the answer. So we got to take what they're giving us. Just like offense, you take what the defense is giving you, because the defense can't cover the whole field. They think they can, but they can't. They're giving up something. So then I plugged in the rest of this stuff, and it was time to get rid of the 4/3. That is tricky. Flip it upside down and multiply. And whatever you do to the left, you do to the right. These two are going to cancel each other out. I know they're not next to each other, but it's okay. I didn't give myself any room to do it over here. That cancels, that cancels, that cancels. They're all dead. The survivors come down. And then we had to do our work. That's a fraction. So I always draw, whenever I do multiplying or whatever, a fraction next to a whole number, I make that and that at the same level to remind myself there's a space down here for that ghost 1. Multiply across top, get 684, and that's the trap right there. Because that number times itself 3 times was that. And they are diabolical. GED.
And that's what they want you to do, so you can think that's the answer.
That's what the D stands for in GEDs. Diabolical. Just plain evil.
Okay.
And then we divide down. Got 171. We put the pi still there, which is cool. So we put that one on trial. Got a number that was too big. So we dropped down and got it, and that was right. A lot of steps. This is one that takes time, but it's not so bad. And anytime you're dealing with pi, keep it as the Greek letter as long as we can. Because if we had to go to 3.14, we could have, but we didn't have to because it's still right there. Hooray.